How far does the Milky Way truly reach? And how much of its vastness has been hiding simply because our eyes were never meant to sense such faint, distant light? The question drifts through the mind like a quiet ripple across deep water, inviting you to lean into the mystery rather than solve it. The more astronomers uncover, the more the edges of our galaxy dissolve into something larger, softer, and far more intricate than we ever believed. Welcome back, traveler. Tonight, we drift through science. Let the noise of your day settle behind you like dust sinking through sunlight. The night feels gentler now, as though it expands slightly with each breath you take. Nothing here asks for effort. The darkness around you is calm, steady, and ready to carry your thoughts into quiet places where the universe feels close enough to touch. A picture slowly forms, spiral arms glowing like scattered brushstrokes across the sky, stretching outward into a halo so vast and dim that generations of astronomers assumed it wasn't there at all. Yet deeper surveys began revealing rivers of ancient stars, hidden tidal streams, distant clusters, and faint structures orbiting far beyond the Milky Way's visible disk. What we once pictured as a flat, elegant pinwheel is actually a sprawling, multi-layered realm extending hundreds of thousands of light years in every direction. You settle a little deeper into the moment as that realization sinks in. The night around you seems to widen, as though mirroring the galaxy's true size. There's something peaceful about understanding that our cosmic home is grander and more intricate than the simple drawings we grew up with. And if these calm journeys through the universe help you unwind or bring a little light into the quieter hours of your day, I'd be grateful if you gently tapped the like button and subscribe to the channel. Small gestures like that help others find their way into this calm corner of the cosmos as well, one sleepy mind at a time. And as your breath softens, another thought begins to rise, an invitation to follow these hidden structures farther outward, into the regions where the Milky Way's faint outskirts quietly reveal just how enormous our home truly is. The Milky Way has always felt familiar, a glowing river arcing across the darkness, but familiarity can disguise immensity. For centuries, people assumed the band of light we see overhead revealed the galaxy's full shape. The curve looked complete, the glow felt contained, and the scale seemed understandable. Yet nearly everything we believed about the Milky Way was built from the slice of it we could see, not from the structure that actually exists. Modern astronomy adds layers to this picture with astonishing clarity. Instruments like Gaia, the Sloan Digital Sky Survey, and deep infrared mapping show that our galaxy isn't a flat disk with tidy spiral arms. It's warped, twisted, rippled by ancient collisions, and surrounded by a colossal halo that stretches far beyond anything visible from Earth. The simple diagrams in textbooks capture only the brightest portion. The real galaxy is several times larger, heavier, and more complex. If you imagine the Milky Way as a lantern seen through fog, the disk would be the concentrated glow, but the halo would be the wide, faint shimmer extending quietly around it. That outer brilliance is so subtle our eyes can't perceive it directly, yet it makes up a significant fraction of the galaxy's total size. Like moonlight spreading across a lake, the halo is present, even if its edges blur into darkness. Thoughts like this make the familiar night sky feel suddenly deeper. Something you've looked at all your life becomes a doorway rather than a boundary. For a long time, astronomers believed the Milky Way stretched about 100,000 light years across. It was an elegant number, large, symmetrical, satisfying, but deeper mapping revealed that this was merely the width of the bright disk. The galaxy's true outskirts extend far beyond that tidy circle, carried by dim stars and ancient clusters scattered across the halo. Some estimates now place the full diameter closer to 200,000 light-years, while others suggest 250,000 or more. This expansion of scale comes from measuring motion. When Gaia tracked the movements of millions of stars over years, the data exposed structures that textbooks never mentioned. Vast streams of stars tracing the paths of shredded dwarf galaxies, distant clusters orbiting at impossible distances, and gravitational patterns shaped by unseen dark matter. Suddenly, the galaxy's edge was no longer clear. It was porous, expanding, filled with remnants of past interactions. Picture a forest seen at night. At first, you notice only the closest trees lit by the moon, but as your eyes adjust, more trunks appear, then faint outlines beyond them, then shadows stretching farther than you thought the forest could reach. The boundary dissolves into layers. Such discoveries remind us that edges often reveal more about our limitations than about the world itself. The Milky Way's shape becomes even stranger when viewed in 3 dimensions. Rather than a clean, flat disk, the entire structure bends upward on one side and dips downward on the other, like a slowly waving sheet caught in a breeze. This warp was first suspected decades ago, but recent mapping confirms it with extraordinary precision. Scientists believe this distortion came from gravitational interactions, perhaps with the Sagittarius dwarf galaxy, which has plunged through the Milky Way multiple times. Each passage tugs on the disk, pulling stars upward or downward in slow motion. The ripple isn't visible to the naked eye, but it affects billions of stars across vast distances. Visualizing this warped disk feels like watching gentle waves roll across an enormous field of glowing particles. The surface rises, dips, casts soft gradients of brightness, and subtly reshapes the galaxy's silhouette. It's a reminder that even immense structures can bend and flex when touched by external forces. Reflections like these highlight a truth that feels surprisingly human. Nothing stays rigid in the universe. Everything learns to move. One of the most surprising discoveries came from studying the Milky Way's stellar halo. This halo isn't a simple sphere of scattered stars. It contains streams, shells, arcs, and remnants of galaxies that merged with us long ago. Some of these stars orbit tens of thousands of light years above or below the disk, forming faint patterns like ancient writing in the dark. The halo's composition tells a story of collisions. Each stream corresponds to a dwarf galaxy pulled apart by the Milky Way's gravity. Its stars stretch into long ribbons, wrapping around the galaxy in enormous loops. One of the most famous, the Sagittarius stream, nearly encircles the Milky Way, its debris spread across the sky in multiple arcs. Imagine trails left by drifting lanterns in the night, each arc tracing the echo of something that once existed whole. These stellar ruins reveal how our galaxy grew, not peacefully, but by absorbing smaller neighbors over billions of years. From these structures emerges a gentle reminder. Even giants are shaped by the things they consume and the encounters they survive. The true scale of the halo only becomes clear when we look at its density, or rather, its surprising lack of it. The stars in the halo are incredibly sparse, separated by enormous distances. But even sparse structures become meaningful when they extend across hundreds of thousands of light years. The halo may be faint, but its reach is enormous. Measurements of globular clusters, ancient, tightly bound spheres of stars, show that some orbit at distances far beyond the visible disk. These clusters act as markers, outlining the galaxy's gravitational domain. When their paths were mapped, astronomers realized the Milky Way's true boundary must be much farther out than previously believed. Visualizing this is like viewing a lighthouse's glow across a foggy sea. The core is bright, but the faintest rays reach astonishing distances before they finally disappear. The halo stars behave the same way. Their tiny numbers don't diminish their extraordinary span. Such awareness inspires a quiet thought. Scale is rarely obvious at first glance. It reveals itself slowly, like a secret whispered across time. Dark matter deepens the mystery further. The Milky Way's visible stars and gas account for only a fraction of its mass. Surrounding the entire system is a massive halo of dark matter, extending possibly 1 million light-years in diameter. It forms the invisible skeleton that holds the galaxy together, determines its rotation, and shapes its interactions with neighboring galaxies. Scientists detect this dark matter not by seeing it, but by measuring how fast stars orbit the center. They move far too quickly to be held by visible mass alone. Something unseen must be exerting gravitational pull. That something accounts for most of the galaxy's mass, an unseen ocean surrounding the bright island of stars. Envisioning dark matter feels like imagining wind shaping a forest. You don't see the wind itself, but its presence defines how the trees move, how the leaves fall, how the landscape breathes. And from that imagery comes a quiet reflection. The most influential forces in our lives are often the ones we can't see directly. Far beyond the bright spiral arms lies a territory few people imagine when they think about the Milky Way. These outer regions aren't drawn in the simple diagrams we grow up with. They fade into temperatures colder, stars older, and structures more delicate than anything closer to the center. Yet these outskirts may be the key to understanding how enormous our galaxy truly is, expanding its borders into realms we barely detect. When astronomers measured the farthest hydrogen gas clouds orbiting the Milky Way, they discovered that these clouds extend far past the visible disk, sometimes more than 50,000 light-years beyond where the starlight fades. Neutral hydrogen emits a signature radio wave that cuts through dust and darkness, revealing motion and distance. Mapping these signals showed that our galaxy's gaseous envelope is massive, lopsided, and still interacting with gravity on colossal scales. The image evokes a lantern surrounded by faint smoke illuminated only at its edges. You don't notice the smoke at first, but once you do, you realize it occupies far more space than the lantern itself. The Milky Way's gas behaves similarly, subtle, transparent, yet vast enough to reshape our understanding of its size. Thoughts like these soften the mind into wonder. Even familiar places have hidden layers when seen through deeper lenses. One of the most astonishing discoveries came from observing the galaxy's vertical thickness. For years, we believed the Milky Way's disk was relatively thin, a few hundred light-years thick in the spiral arms, but newer surveys revealed that stars extend thousands of light-years above and below the disk, forming a thickened structure shaped by past interactions. Gaia's measurements uncovered entire groups of stars oscillating above the galactic plane, moving as if responding to an ancient disturbance. These oscillations suggest that something massive, likely the Sagittarius dwarf galaxy, passed through the disk repeatedly, lifting entire regions like waves rippling across a wide, glowing cloth. If you imagine a sheet of water shimmering after a stone is dropped in cha, the motions resemble what Gaia observed. The disk is not smooth, it's stirred, rippled, alive with subtle vertical tides. These motions expand our understanding of the Milky Way's vertical reach beyond previous estimates. Such complexity sparks a realization. Structure is not always symmetry. Sometimes it is movement held in slow suspension. Even the spiral arms themselves challenge the simplicity we once imagined. The traditional picture shows 4 elegantly defined arms, curling outward from the center, like the petals of a cosmic flower. But as infrared and radio observations improved, astronomers discovered that these arms are not continuous structures at all. They're patchy, fragmented, woven from clusters and clouds that don't always line up neatly. Simulations suggest that spiral arms behave like traffic jams in a city. Clusters of stars move in and out of compressed regions, making the arms appear stable even though individual stars constantly leave and enter them. This dynamic structure extends farther than the bright portions indicate, pushing the arms outward into faint, sparsely populated regions. Visually, this resembles fireworks captured in slow motion, bright streaks fading into subtle trails, with faint sparks drifting farther than you'd expect. The arms are not boundaries, they're suggestions, stretching into darkness with surprising reach. Such insights whisper a gentle truth. What appears orderly from afar often reveals deeper complexity up close. The outskirts of the disk are populated by clusters so faint that detecting them feels like catching whispers in a storm. These are ultra-faint dwarf galaxies and sparse star groupings orbiting the Milky Way at extreme distances. Many were discovered only in the last decade, thanks to deeper sky surveys capable of picking up barely perceptible glimmers of starlight. These systems orbit far beyond earlier estimates of the galaxy's size, sometimes over 300,000 light-years away, placing them on the very frontier of the Milky Way's gravitational influence. Their motions reveal the invisible shape of the surrounding dark matter halo, which must be enormous to hold these distant satellites in orbit. To picture their presence, think of distant fireflies hovering at the edge of a vast field. Their lights are faint, but their positions outline the unseen perimeter. These tiny galaxies, nearly invisible, trace the Milky Way's true scale more faithfully than the bright spiral arms ever could. Their existence reinforces a comforting idea. Even the faintest signals have stories worth following. Another surprising feature lies in the star streams threading through the halo like delicate strands. These stellar rivers are remnants of ancient dwarf galaxies and globular clusters torn apart by the Milky Way's gravity. Their debris stretches across tens of thousands of light-years, forming arcs and loops that wrap the galaxy like quiet signatures. Modern surveys mapped dozens of these streams, each one a quiet relic of a cosmic encounter. Their distribution revealed that the halo is not smooth. It's textured, laced with the remnants of interactions spanning billions of years. Some streams reach distances so vast, they redefine where the galaxy's influence ends. Visualizing these structures feels like watching ribbons carried by a gentle wind, sometimes tight, sometimes loose, always drifting through space with a slow, ethereal grace. They remind us that the Milky Way was shaped through countless interactions, each leaving behind faint traces. Such features spark an inward reflection. History, even when stretched thin, still leaves patterns. The discovery of the Gaia Enceladus event dramatically expanded our sense of the galaxy's true scale. This ancient merger, which occurred billions of years ago, brought in a massive dwarf galaxy whose stars now populate a large portion of the Milky Way's inner halo. These stars move on elongated radial orbits, plunging through the disk and soaring far above it. This realization reshaped our understanding of the galaxy's structure. The Milky Way isn't merely a spiral system, it's a blend, a composite, a layered artifact of cosmic collisions. The motions of these stars extend far beyond the disk's edge, stretching the effective size of the halo significantly and revealing a past far more chaotic than once assumed. The imagery resembles a flock of birds circling in wide patterns, their paths overlapping but distinct, forming shapes that only become visible from a distance. These stars carry the memory of a galaxy that no longer exists, spreading its influence across the Milky Way's full expanse. And from their movements emerges a quiet idea. We are part of a home built from many homes before it. The more we study the Milky Way, the clearer it becomes that our home galaxy is not a static shape, but a living structure. Its stars shift, bend, oscillate, and breathe across enormous spans of time. What appears calm from Earth is, in reality, a slow choreography of billions of suns tracing paths shaped by gravity. collisions, and the lingering memory of ancient encounters. The galaxy is not simply big, it is dynamic, ever-changing, and layered with motion. Astrophysical data from Gaia revealed something astonishing. Stars in the disk don't all orbit smoothly. Instead, groups of them rise and fall through the galactic plane, creating vertical waves that ripple across tens of thousands of light years. These undulations likely come from interactions with dwarf galaxies passing through the Milky Way, stirring the disk like a spoon moving through thick liquid. Each passage leaves behind a subtle signature of motion. Visually, this creates the impression of a glowing sheet of light caught in a gentle breeze. The galaxy bends upward in one region, dips downward in another, forming curves so vast they're impossible to grasp from within. Yet they're real, and they show the Milky Way as something flexible rather than rigid, a structure shaped continuously by cosmic tides. Reflections like these reveal a calming truth. Even immense systems learn to sway with their surroundings rather than resist them. One of the most striking discoveries is the presence of a massive wave of stars called the Radcliffe Wave. This structure is a long, undulating chain of star-forming regions stretching roughly 9,000 light-years across the galactic disk. It rises and falls like an enormous cosmic sine wave, weaving through the Milky Way's spiral arms with quiet elegance. Researchers identified it by mapping the positions of molecular clouds and young stars, realizing they aligned along a single, connected structure. Its shape suggests that something, perhaps a past collision or an internal instability, sent a ripple through the disk that continues to propagate slowly over millions of years. Imagine a ribbon drifting through water, lifting and sinking as it moves forward. The Radcliffe Wave carries that same kind of visual softness, a reminder that the galaxy is filled with patterns we cannot see from our vantage point on Earth. Thoughts like this inspire a sense of awe. Even the spaces between stars hold hidden choreography. Another layer of structure appears in the galaxy's bar, a dense, elongated cluster of stars at the Milky Way's center. For decades, we pictured the core as a simple bulge, but infrared observations revealed a bar stretching nearly 27,000 light-years across. This bar funnels gas toward the center, feeding star formation and shaping the rotation of the inner disk. Mathematical models show that the bar influences orbits far beyond its visible length, guiding stars along long loops that extend outward into the spiral arms. Without the bar's gravitational pull, the Milky Way's spiral structure might be far less pronounced. The arms could be looser or even chaotic. Picture a slow whirlpool, its currents guiding leaves into graceful arcs. The bar plays a similar role, pulling material inward and helping the spiral arms maintain their broad, sweeping shape. Such dynamics illustrate a comforting idea. Structure often emerges from flows rather than boundaries. Even the spiral arms themselves are far more complex than early astronomers believed. Instead of clear, continuous curves, they consist of segments, bright stretches interspersed with gaps, branches, and spurs. These irregularities form because spiral arms are density waves, not physical objects. Stars move in and out of them, compressing gas as they pass through and creating temporary bright regions. Radio observations of hydrogen gas show that the arms extend farther than the visible stars suggest. Some arms form long, faint extensions reaching deep into the galaxy's outskirts, making the Milky Way's shape more expansive and intricate than the iconic illustrations seen in books. In imagination, these arms resemble rivers flowing through a vast landscape. Some branches remain deep and steady, while others split into narrow channels before fading into quiet marshes. The flow continues, always shifting. These patterns remind us gently that structure and impermanence can coexist. Adding to this complexity is the discovery of feathers, thin, elongated streams of stars branching off the spiral arms. These features appear as faint diagonal streaks cutting across the disk, connecting different regions like subtle brushstrokes across a canvas. Their origin remains uncertain, but simulations suggest they may form when dwarf galaxies pass close to the Milky Way, tugging loose strands of stars. Gaia's star mapping revealed dozens of these feathers, each one delicate and faint, but stretching across thousands of light years. Their shapes add yet another layer to the galaxy's architecture, one that is almost invisible, but profoundly beautiful. Visualizing them feels like watching threads pulled gently from a woven cloth, drifting outward, but still connected to the whole. Their presence shows that even small interactions leave artwork behind in the stars. Such details encourage the quiet understanding that beauty often forms in the subtlest patterns. Farther from the disk, the Milky Way reveals another structure, the stellar river known as the anticenter stream. This long, faint feature stretches outward from the galaxy's far edge, hinting at an ancient merger or a disrupted cluster orbiting on unstable paths. Its stars move on orbits that extend far beyond the main disk, almost like comets compared to planets. The stream's shape indicates that it may wrap around the galaxy multiple times, forming loops that trace the gravitational influence of the dark matter halo. Mapping it helps astronomers estimate the Milky Way's mass and the true reach of its gravitational grasp. Picture a long trail of drifting embers carried by a slow wind. Some burn brightly, others glow faintly, but together they mark a path through the darkness that would otherwise be invisible. These images lead to a thoughtful recognition. Remnants carry stories long after their origins fade. The galaxy's vertical structure hides yet another astonishing feature, the monoceros ring. Initially dismissed as a warp in the disk, it was later recognized as a giant stellar structure wrapping around the galaxy like a wide ribbon. It extends tens of thousands of light years above and below the disk, making it one of the Milky Way's most prominent outer features. Astronomers now believe the monoceros ring may be debris from a dwarf galaxy that was partially absorbed, leaving behind a vast arc of stars. Its size pushes the Milky Way's effective diameter outward, suggesting our galaxy is not just larger than expected. It's intricately layered with structures formed by past interactions. In the mind's eye, it resembles a shimmering arch around a lantern, faint but sweeping, transforming the outline of the light it encircles. Such discoveries evoke a calming realization. Complexity often reveals itself only through patience and deeper observation. Even closer to home, the Sun's orbit takes us through regions shaped by these hidden structures. As the solar system completes each 230 million-year rotation around the galactic center, it passes through spiral arms, grazes subtle waves, crosses regions influenced by past mergers, and moves within the ebb and flow of the disk's vertical motion. The galactic environment is not static. It changes slowly but continuously. Astrophysicists model these variations to understand how the Sun's journey affects cosmic rays, star formation rates, and even the potential environments that shaped early Earth. Although the effects are subtle, they remind us that the solar system is part of a much larger dance, one governed by motions too slow to perceive in a single lifetime. Imagine riding a gentle current through a vast ocean. The water shifts around you, currents rise and fall, and temperature gradients change subtly over time. You don't feel the motion directly, but it shapes your entire path. Such imagery reveals a profound thought. Even when life feels still, we are always moving. Astronomers once assumed the Milky Way ended where the visible stars thinned into darkness, but deeper surveys revealed something far more expansive. What appears black to the naked eye is often filled with faint red dwarfs, scattered clusters, and wisps of gas illuminated only slightly by distant starlight. Our galaxy's outskirts are not empty. They are simply quiet, subtle, and difficult for human senses to perceive. Modern telescopes like Gaia and the Sloan Digital Sky Survey uncovered regions where stars drift in sparse, ghost-like arrangements. These stars possess low luminosity, making them nearly invisible from Earth, yet they extend the Milky Way's radius far beyond earlier estimates. Their presence adds tens of thousands of light-years to the galaxy's true size, reshaping our understanding of its boundaries. A mental picture forms softly, delicate pinpoints glowing behind a veil, like tiny lanterns hidden within thick fog. They shimmer faintly, as if attempting to whisper their existence to anyone patient enough to listen. This delicate glow stretches outward into the dark, suggesting a vastness more poetic than intimidating. It invites a quiet reflection. The most powerful realities are often the hardest to see. Recent discoveries show that the Milky Way contains a massive population of ultra-faint dwarf galaxies orbiting in the outer halo. Most of these companions are so dim that even long-exposure imaging struggles to detect them. Yet they orbit the Milky Way like loyal satellites, influencing gravitational flows, stirring star streams, and hinting at a complex history of mergers. Observations reveal that many of these dwarf galaxies align in a planar structure, almost like beads on a cosmic necklace. Whether this alignment is a coincidence or a relic of a past event remains uncertain, but their collective presence expands the sphere of influence of the Milky Way dramatically, pushing the galaxy's effective size to nearly 2 million light-years. Visualizing them evokes the idea of tiny fireflies hovering around a bright campfire, each moving independently, yet still drawn to the central glow. Their dimness doesn't diminish their importance. Instead, it highlights the subtle architecture orbiting far beyond the familiar spiral arms. And through that image, a thought emerges. Even the smallest companions reshape the identity of the whole. In addition to faint dwarf galaxies, streams of stars stretch across the halo like elongated ribbons. These streams form when small galaxies or globular clusters are torn apart by tidal forces, leaving behind trails of stars that trace their past orbits. Each stream acts like a fossil, preserving the history of ancient interactions that occurred long before humans existed. One stream, known as the Sagittarius stream, wraps around the Milky Way in giant loops. It is made of stars stripped from the Sagittarius dwarf galaxy as it plunges repeatedly through the Milky Way's disk. Each crossing injects waves of energy into the galaxy, subtly reshaping its structure and star formation patterns. You might visualize these stellar trails as threads unraveling from a slowly turning tapestry. Their gentle arcs curve across vast distances, evidence of a cosmic history too large to capture in any single moment. They drift through space like memories stretched into motion. A quiet realization follows. Even destruction produces patterns of unexpected beauty. Observations of the galactic halo also reveal an enormous population of hot, ionized gas surrounding the Milky Way. This diffuse atmosphere, known as the circumgalactic medium, extends hundreds of thousands of light-years into space. Though nearly invisible, it contains more mass than all the stars in the disk combined. It is the galaxy's hidden reservoir, a source of future star formation, and a recorder of past supernovae. NASA's Chandra X-ray Observatory detected clues that this medium forms a kind of cocoon around the Milky Way, heated to millions of degrees by ancient stellar explosions. It glows faintly in X-rays, marking the edges of the galaxy not by starlight, but by temperature and memory. In the mind's eye, it resembles an immense sphere of warm mist, radiating softly like the last embers of an old fire. Here it's not bright, yet it envelops everything, a silent guardian shaping the galaxy's evolution. That image leads to a simple, grounding insight. The boundaries of things often extend far beyond what the eye can measure. The halo is also home to roaming hypervelocity stars, objects moving so quickly that they can escape the gravitational pull of the Milky Way. These stars are launched by rare events, often interactions with the supermassive black hole at the galaxy's center. Their speeds can exceed 1,000 kilometers per second, sending them racing into the deep outskirts. Though few in number, their presence reveals the gravitational landscape of the galaxy's outer regions. Their trajectories stretch the definition of where the Milky Way ends, since a star's ability to escape depends on the mass of the dark matter halo, which extends much farther than the visible galaxy. Picture a single spark shooting away from a campfire, carried upward by a sudden burst of hot air. For a moment, it glides far beyond the glowing circle of light, showing just how large the influence of the fire truly is. Thoughts like this remind us gently that influence is often larger than presence. Far beyond the spiral arms, astronomers have detected enormous clouds of neutral hydrogen gas drifting at the fringe of the halo. These clouds may be remnants of interactions with dwarf galaxies or inflows of material from the intergalactic medium. Some appear to be falling toward the Milky Way, feeding the disk with fresh material that may one day form new generations of stars. Radio telescopes reveal their shapes as long, diffuse structures stretching across the sky. Their edges blur softly into the background, like distant fog banks in a twilight landscape. Though they glow faintly in radio wavelengths, they remain invisible to the naked eye, contributing to the galaxy's hidden mass. The mental image resembles slow-moving banks of mist drifting in a cavern lit only by distant torches. They carry the quiet promise of renewal, of future light not yet born. And through this, a peaceful idea emerges. Even the coldest, emptiest spaces carry seeds of creation. Deep mapping of these outer regions has also revealed stellar shells, curved arcs of stars shaped by past galaxy collisions. These shells form when a smaller galaxy plunges into a larger one, its stars thrown into oscillating orbits that pile up in dense arcs at their turning points. The Milky Way's halo contains multiple shells, evidence of at least a few significant mergers over the past few billion years. Each shell marks a point where stars slow momentarily before falling inward again, creating faint, overlapping ripples that extend outward like rings in a pond. The analogy is nearly perfect. A disturbance, a spreading pattern, a gradual softening into stillness. You might envision these shells as delicate crescents of light traced across dark water, each one hinting at an event long since faded. They're subtle, almost invisible, yet undeniably real. Reflections arise naturally here. Even the quietest remnants speak of dramatic histories. As researchers continue to expand the known size of the Milky Way, a new understanding begins to take shape. The galaxy is not a flat disk with clean edges. It is a multi-layered structure whose boundaries dissolve gently into surrounding space. Each discovery pushes the limits outward, revealing a galaxy far larger, softer, and more complex than textbooks once suggested. This fresh perspective transforms the way we think about our place in the universe. We are not floating near the outskirts of a modest spiral. We are embedded deep within a colossal, sprawling structure whose true shape continues to unfold with every generation of telescopes. Visualize this revelation as a lantern slowly brightening, illuminating more of the room around it. The walls expand not outward, but inward, revealing that the space was always larger than you assumed. Such an understanding leaves a quiet imprint. Reality often grows as awareness deepens. And as you consider this immense, extended architecture, a gentle thought rises. The more we uncover, the more the galaxy seems to breathe with its own rhythm. Its outskirts pulse with streams, shells, clouds, and ultra-faint companions, a mosaic of features shaped by billions of years. This awareness doesn't overwhelm, it softens. It creates a sense of belonging, of drifting within something ancient yet alive. The galaxy's vastness becomes not a void, but a cradle of light and motion. And with that calm feeling settling in, the journey drifts forward into what else the Milky Way is hiding beyond what our eyes alone can see. Across decades of research, astronomers realize the Milky Way's disk isn't a perfect plane at all. It bends, tilts, and warps like a sheet of fabric caught in a slow, cosmic breeze. This discovery reshaped the way we imagine our galaxy. Instead of a rigid, structured wheel, the Milky Way behaves more like something alive, its outer regions undulating gently as gravitational forces tug at it from every direction. Surveys using radio telescopes revealed that the hydrogen gas in the disk doesn't lie flat. Instead, the outer edges rise on one side and fall on the opposite, creating a smooth twist that spans tens of thousands of light years. Stars follow this pattern as well, forming a subtle three-dimensional shape that can only be seen when the galaxy is observed from far away. The picture feels like watching a calm ocean swell under moonlight, broad, slow waves rolling without urgency, shaping the surface in a rhythm that feels almost biological. The Milky Way doesn't sit still. It curves, breathes, and leans into the forces acting upon it. That realization carries a quiet wisdom. Even massive structures respond gracefully to the pressures around them. A likely cause of this warp lies in the gravitational pull of satellite galaxies orbiting the Milky Way. Among them, the Large Magellanic Cloud, LMC, plays a special role. This bright dwarf galaxy, visible in southern skies, is not merely passing by. It is interacting with the Milky Way's dark matter halo in a way that produces a gravitational wake, pulling on our galaxy's disk as it moves. Simulations from researchers at Harvard and the University of Arizona showed that the LMC's influence can generate ripples that move through the Milky Way like waves in a stretched drumhead. These distortions travel slowly, taking hundreds of millions of years to complete a single oscillation. Their motion is so gentle that no person, no civilization, no species could ever perceive it directly. In the imagination, this becomes a picture of two cosmic dancers drifting around one another, enormous but graceful, leaving trails in the fabric of space like patterns carved by slow tides. Their interaction is ancient, delicate, and ongoing. Thoughts settle naturally around this idea. Even across unimaginable scales, relationships leave imprints. As the disk warps, it also flares, becoming thicker toward the edges. Near the center, stars orbit in a relatively thin layer. But farther out, the disk widens into a soft, diffuse structure. This flaring effect indicates that stars in the outer regions move with more vertical freedom, as if gravity's grip loosens slightly with distance from the core. Measurements show that this vertical thickening grows progressively outward, adding thousands of light years to the Milky Way's height. The reason lies in the complex dance between stars, gas clouds, and dark matter. The less tightly bound regions of the galaxy allow stars to oscillate above and below the midplane more easily, creating a gradual feathering effect. A visualization emerges. The galaxy resembles a long flowing ribbon with edges that spread outward like the ends of a fabric caught in a slow turning breeze. The pattern is not abrupt. It is gentle, almost sleepy, like breath expanding and contracting in deep rest. The feeling it evokes is simple. The edges of things are often softer than we assume. Interactions with the Sagittarius dwarf galaxy also contribute to this dynamic structure. Every time this smaller galaxy plunges through the Milky Way's disk, it disrupts gravitational equilibrium. These repeated crossings inject waves of energy into the disk, stirring the stars and gas in ways that accumulate over billions of years. Data from Gaia revealed vertical oscillations in the disk, stars moving up and down in coordinated patterns, like ripples spreading across a pond after a stone is thrown. These motions offer evidence that the Milky Way's shape has been shaped not by a single event, but by an entire series of past encounters. The imagery feels serene, ripples broad and slow, migrating outward until they fade into stillness. Nothing about these waves is violent at a human timescale. They move with the patience of cosmic seasons, shifting subtly as epochs unfold. From that picture comes an understanding. Change, even when dramatic in scale, can occur quietly. Beneath the disk's bending and flaring lies another subtle feature. The stellar warp isn't symmetrical. One side of the galaxy lifts slightly higher than the other, producing a lopsided form that suggests ongoing gravitational influences. This asymmetry hints at unseen structures, perhaps dark matter clumps, or remnants of long-lost galaxies swallowed by the Milky Way. Astronomers continue to map these distortions using precise stellar motions measured across millions of stars. Each data point, each orbit, each faint shift helps refine the image of a galaxy that behaves less like a rigid machine and more like a living, breathing system responding to its environment. Visualizing this, you might imagine a large, flexible disk floating atop invisible currents, rising, dipping, adjusting. The motion is slow, fluid, and quietly expressive, revealing the Milky Way's history through its posture. And in that posture lies a reflection. The past shapes the present in ways we rarely notice. The more scientists study these warps and flares, the clearer it becomes that the Milky Way has absorbed many smaller galaxies throughout its lifetime. Each merger leaves signatures in the motions of stars, in the distribution of gas, and in the shape of the disk. Some of these signatures are sharp, but most are subtle, faint echoes rather than scars. Observing them feels like reading a story written in layers, where each chapter blends softly into the next. Every generation of astronomers uncovers new hints, a wave here, a discontinuity there, a faint overdensity drifting quietly across the halo. A poetic image emerges. The Milky Way is a palimpsest, a manuscript written over countless times, with traces of every earlier version still faintly visible beneath the latest lines. The thought brings a certain peace. The universe remembers, even when it whispers rather than speaks. Another element of the Milky Way's evolving structure lies in the outer spiral arms, which are far more loosely wound than the inner ones. These arms stretch outward like long, delicate filaments, rarely packed with dense star formation. Instead, they serve as grand, extended pathways where gas and stars drift more freely. Radio maps show that some arms may branch, bend bracts, or even dissolve into the halo, blending with faint streams of hydrogen. Their shapes reflect gravitational interactions, density waves, and historical collisions. At such distances, the spiral pattern becomes a suggestion more than a rule. The image resembles a watercolor painting where the edges fade gently into the page, creating a soft boundary that feels more dreamlike than mechanical. These outer structures don't define the galaxy sharply, they blur it, and the lesson they carry is understated. Not all borders are meant to be precise. Even the central bar of the Milky Way influences the disk's breathing motion. This elongated structure of stars rotates as a solid unit, channeling gas inward and shaping the inner spiral arms. Its rotation is slow compared to human intuitions, taking hundreds of millions of years to complete a revolution. The bar acts like a metronome for the galaxy, guiding flows of matter and affecting the gravitational balance across vast distances. Its presence contributes to the warp subtly, stretching and twisting the disk as it interacts with surrounding structures. Visualizing this, You might picture a gentle twist in a long ribbon caused by someone turning their wrist ever so slightly. The motion is delicate but persistent, a whisper rather than a shove. The idea carries a peaceful truth. Structure and motion coexist in harmony, even when forces are immense. Taken together, the warp-flare oscillations and tidal imprints show that the Milky Way is not a still photograph. It is a slow, evolving dance. Each component moves with patience, shaped by influences both near and distant. Over time, the galaxy shifts like a vast cosmic tide, changing form while maintaining identity. This understanding brings a soft reassurance. If galaxies spanning hundreds of thousands of light years can shift and reshape without losing themselves, then perhaps change, even on the scale of human life, is not something to resist, but something to flow with. The thought settles gently as the journey continues, inviting you deeper into the structures that define our ever-growing home. Every galaxy carries a set of invisible currents flowing beneath its glowing stars, and the Milky Way is no exception. These currents are not made of water or wind, but of gravitational fields weaving through space like soft, unseen rivers. Their presence shapes everything, from the paths of stars to the movement of entire stellar streams drifting slowly across the halo. Understanding them reveals a deeper truth. Our galaxy's behavior is guided by forces we cannot see, but can feel through careful measurement. Astronomers study these currents by tracking stellar motion with exquisite precision. The European Space Agency's Gaia mission maps the positions and velocities of more than 1 billion stars, capturing their motions in 3 dimensions. When these movements are combined, patterns emerge: slight drifts, gentle waves, and coordinated flows hinting at hidden structures shaping the galaxy from within. That view transforms the Milky Way into something more fluid, like a vast ocean whose surface sparkles with stars, while its depths remain quiet and dark. You can almost imagine schools of stars gliding along these gravitational pathways, following currents carved over billions of years. The idea leaves a calming impression. Even the most enormous systems follow gentle rhythms beneath their surface. Some of these currents are the remnants of ancient collisions, preserved long after the galaxies involved disappeared. When a smaller galaxy merges with the Milky Way, its stars don't scatter instantly. They drift along, forming streams that wrap around the halo like delicate ribbons. These streams curve, twist, and stretch over thousands of light years, recording the memory of encounters long past. One of the most famous examples is the Sagittarius Stream, a vast arc of stars torn from the Sagittarius dwarf galaxy as it orbits and gradually dissolves into the Milky Way. Gaia's measurements show the stream looping around the galaxy multiple times, a cosmic fingerprint of an ongoing merger. Even though the original galaxy is slowly being consumed, its stars continue to move in graceful patterns. The mental picture becomes serene, a long silver thread trailing behind a drifting lantern, its glow fading but never disappearing. Each turn of the stream records an orbit, each orbit records an era, and from that comes a quiet lesson. The past doesn't vanish, it simply widens into the present. Other currents reveal themselves in the behavior of stellar groups moving in harmony. These are called moving groups or stellar associations, clusters of stars that form together and now travel through the galaxy as coherent units. Over time, gravitational interactions stretch them apart, but their shared motion remains, like cousins drifting along parallel paths. Some of these groups are ancient, born when the Milky Way was still young. Others are more recent, created within giant molecular clouds that have long since dispersed. Their collective motion helps astronomers map the shape of the galaxy's gravitational potential. the landscape that stars move through, full of hills, valleys, and hidden folds created by visible matter and dark matter alike. It's soothing to picture them as small flocks migrating through the cosmic landscape, following invisible routes laid out by forces older than any star within them. Their motion is calm, coordinated, and slow enough to be timeless. The reflection lingers. Belonging can exist even when distance grows. Beneath the disk, even deeper currents whisper through the dark matter halo enveloping the Milky Way. This halo is immense, far larger than the visible galaxy, and almost completely invisible. Yet its gravity shapes the motion of every star, every cloud, every orbit. Without it, the Milky Way would simply fly apart. With it, the galaxy holds together in a wide, soft embrace. Simulations suggest that the halo isn't perfectly smooth. Instead, it contains clumps, filaments, and subtle asymmetries created by past mergers and cosmic evolution. As stars move through these regions, their paths shift ever so slightly, producing waves and oscillations detectable on grand scales. In imagination, the halo resembles a vast, translucent sphere filled with quiet eddies, not turbulent, but peacefully textured. Stars drift through it as leaves glide across a shallow stream, adjusting their course without ever realizing they've changed direction. That image brings a simple truth. Even the unseen has structure. Some of the most delicate currents show up in vertical oscillations of the disk. These oscillations, discovered through Gaia's star maps, reveal that stars move up and down relative to the galaxy's midplane in coordinated patterns. It's as if the Milky Way experiences a slow breathing motion, rising and falling in cosmic inhalations and exhalations spanning hundreds of millions of years. Researchers believe these waves were triggered by past interactions with smaller galaxies. When the Sagittarius dwarf galaxy plunged through the disk, it created ripples that propagated outward like waves on a vast pond. These waves are still traveling today, their amplitude so gentle that no living creature could ever detect them directly. The scene feels strangely soothing, a galaxy breathing in slow motion, its inhalations measured in epochs, its exhalations drifting through the halo. The movement is balanced, quiet, and profoundly patient. The reflection is clear. Stillness and motion are often two parts of the same rhythm. Layered within these currents are faint traces of the Milky Way's earlier structure. When the galaxy first formed, its stars moved in chaotic orbits. Over billions of years, interactions with gas, dark matter, and smaller galaxies transformed that chaos into order. Yet some stars still carry the signature of those early days, erratic motions that set them apart from the rest of the disk. By studying these stars, astronomers reconstruct the galaxy's earliest history. Their paths tell stories of turbulence, collisions, and the slow settling of matter into the graceful spiral we see today. Each orbit holds clues about the forces that shaped the Milky Way before humanity existed. Visualizing this, the galaxy becomes a layered sculpture, each motion representing a different era. Some movements are smooth, others jagged, but together they create a tapestry of motion woven across cosmic time. And with that tapestry comes a feeling of awe. Even chaos can become harmony with enough time. As researchers trace these motions, they uncover evidence of a phenomenon known as phase mixing. This happens when stars that began moving together gradually disperse and blend into the broader population. Their paths stretch, fold away, and eventually smooth out, like a drop of dye swirling into water until it becomes part of the whole. Phase mixing explains why some stellar structures appear sharp, while others blur into indistinct streams. It also reveals why the galaxy's interior feels so uniform, even though it was once full of clumps and irregularities. Time softens and reorganizes everything. turning distinct features into gentle gradients. The metaphor almost writes itself, identity dissolving into unity, not lost, but transformed. A star once belonging to a tight cluster may now wander alone, but its motion remains part of the galaxy's collective flow. And the lesson is gentle. Blending can be its own form of belonging. Farther from the disk, currents continue in the form of hypervelocity stars. These rare stars move so fast that they can eventually leave the Milky Way entirely. Many are thought to have been flung outward by interactions with the supermassive black hole at the galaxy's center, gaining enough speed to break free from its gravitational pull. Their trajectories offer insight into both the black hole's influence and the shape of the galaxy's outer halo. By tracking them, astronomers draw a clearer map of the Milky Way's gravitational boundary, a vast region where the galaxy slowly gives way to intergalactic space. It's striking to imagine a single star moving across millions of light years, glowing quietly as it drifts into the dark between galaxies. There is loneliness in the image, but also profound freedom. The reflection follows naturally. Not every journey is meant to circle back. Even the motion of the sun participates in these vast currents. Our star orbits the center of the Milky Way at roughly 220 kilometers per second, completing one revolution every 230 million years. As it moves, it oscillates gently above and below the galactic plane, following the same slow breathing of the disk as countless other stars. Earth travels with it, carried along effortlessly. Each second of your life, each breath, each quiet moment unfolds while the entire solar system surfs through interstellar space. We are passengers more than drivers, moving across a galaxy too large to grasp, yet steady enough to feel safe within. The imagery becomes tender, a small, warm world tucked inside an arm of a galaxy, drifting gracefully through a universe that neither rushes nor hesitates, and the thought it invites is grounding. Movement doesn't require urgency. As all these currents intertwine, they create a galaxy shaped not by single forces, but by many overlapping influences. No star moves alone, no stream drifts without context, and no ripple fades without affecting others. The Milky Way is an ecosystem made of motion, a slow, interwoven choreography unfolding across billions of years. Understanding this makes the galaxy feel less like an object and more like a living phenomenon. It is dynamic, adaptive, responsive. The quiet flows running through it hold memory, structure, and direction. Taken together, they reveal a galaxy with far more depth and personality than the flat diagrams of old textbooks ever suggested. This realization lands softly. Even the largest systems carry subtlety in their motion. And with that softness, the journey continues toward deeper regions of the Milky Way, places where motion becomes mystery, and where the galaxy's true scale begins to show itself. Deep within the Milky Way lies a region where gravity tightens, stars crowd together, and time seems to slow, a place often called the galaxy's heartbeat. The central bulge is not the smooth sphere early astronomers imagined. Instead, it stretches into a peanut-shaped structure, warped and elongated by the rotation of the stellar bar that cuts through the core. This shape influences the motion of stars across vast distances, reaching far beyond the bright center. Observations from NASA's Spitzer Space Telescope revealed the bulge's distinct geometry, showing how its elongated form channels gas inward and shapes the orbits of nearby stars. The bulge acts as a gravitational anchor, holding the inner galaxy together while redistributing energy through subtle interactions. Its presence stabilizes the Milky Way's structure, offering a sense of coherence amid perpetual motion. In imagination, it feels like drifting into a softly glowing chamber, dense, warm, and ancient. Stars shimmer like embers suspended in thick, golden smoke, each one humming with slow, patient energy. The picture carries an emotional echo. The center of anything is rarely simple. At the very core, tucked beneath layers of stars, dust and swirling gas, lives Sagittarius A, the Milky Way's supermassive black hole. Despite its frightening name, this black hole is surprisingly calm. It is millions of times the mass of the Sun, yet far quieter than the raging giants seen in distant galaxies. Most of the time, it rests, feeding only on stray gas clouds or fragments passing too close. The Event Horizon Telescope collaboration captured the first detailed images of Sagittarius A case, revealing a glowing ring of gas orbiting the dark center. This turbulent material heats up as it spirals inward, emitting light that allows astronomers to deduce the black hole's size and behavior. Even so, the region remains shrouded in mystery, with magnetic fields and chaotic flows that resist easy explanation. Visualizing it becomes an exercise in calm comprehension, a soft, circular glow surrounding a perfectly silent center. No sound, no rush, only a quiet gravitational presence. The reflection comes naturally. Even immense power can exist in stillness. The black hole is not an isolated phenomenon. It shapes the motion of stars in its immediate neighborhood. Dozens of young, massive stars orbit within a few light days of Sagittarius A, moving so quickly that their full paths can be traced in mere decades. These stars, known as the S-stars, travel in elliptical loops that reveal the black hole's mass and gravitational reach. Their orbits behave like celestial calligraphy, carving elegant curves around an invisible point. Astronomers watch them shift position year after year, forming a cosmic ballet that offers rare insight into gravity at its most extreme. Despite the intensity of the environment, these stars maintain stable orbits, gliding through the core with astonishing precision. The image feels intimate, small, bright lights circling a quiet, dark heart, their motion steady and sure. And from that image rises a quiet thought. Order can emerge even in the most chaotic places. Moving outward from the core, the density of stars begins to thin, creating a gradual transition into the inner disk. This region is rich with molecular clouds, stellar nurseries, and colossal structures like the central molecular zone, a ring of gas spanning hundreds of light years. Here, star formation occurs at a rapid pace, fueled by dense pockets of cold hydrogen compressed by gravity and turbulence. Infrared observations reveal knots of warm dust, protostars wrapped in cocoons, and towering walls of gas sculpted by stellar winds. These features act as stepping stones between the crowded bulge and the more familiar spiral arms. Their distribution reflects the galaxy's rotation, its gravitational gradients, and the flow of matter funneled inward by the central bar. The mental image becomes vibrant. Swirling clouds, faint illumination, drifting shadows, all slowly turning in unison like lanterns carried by a gentle current. The feeling underneath suggests a truth. Creation rarely happens in silence, but its results often feel peaceful. Elsewhere in the inner galaxy, dense star clusters form pockets of extraordinary brightness. These globular clusters are some of the oldest structures in the Milky Way, containing stars nearly as old as the universe itself. They orbit the galaxy's center in long arcing loops, spending most of their time far above or below the galactic plane. Their combined light creates soft, concentrated spheres that hang in the halo like ancient watchful eyes. Each cluster contains hundreds of thousands of stars compressed into a remarkably small space, producing gravitational fields strong enough to resist disruption from the galaxy's tides. They evoke the image of glowing seeds floating in the darkness, each carrying a memory of the early cosmos. And the lesson they hint at is subtle. Age brings clarity, not fragility. Between these clusters and the disk lies the thick disk, a transitional structure populated by older stars with wider, more inclined orbits. This region likely formed through early collisions that heated and scattered stars, lifting them out of the thin disk. Their motions still reflect that early upheaval, moving with a rhythmic, wave-like vertical motion as they orbit the center. Studies comparing the thin and thick disks reveal differences in chemical composition, indicating distinct histories. The thick disk stars contain fewer heavy elements, implying they formed before the galaxy accumulated recycled material from supernovae. Their orbits also show greater dispersion, creating a puffier, more textured structure. Picture it as a soft cushion surrounding the thin disk, aged, calm, and woven with the memory of ancient disruptions. The thought emerges gently. Tension can give way to balance. Crossing through the disk, dust lanes weave intricate patterns that reveal the Milky Way's internal currents. Dust absorbs and scatters starlight, creating dark filaments that intertwine with glowing regions of star birth. These structures trace the movement of gas, showing where spiral density waves compress material and trigger new generations of stars. Radio and infrared surveys penetrate these opaque clouds, exposing the hidden skeleton of the galaxy's inner arms. Some regions glow with bright emission lines, while others remain cold and silent, waiting for gravity to gather them into new structures. The image feels tactile, delicate veins of shadow stretching across a luminous canvas, creating contrast and depth like brush strokes on textured paper. And from that contrast arises a quiet thought. Darkness is not absence, it's structure. The inner spiral arms behave differently from the outer ones. They are tighter, denser, and influenced strongly by the rotation of the central bar. Gas moves along these arms like traffic flowing down wide cosmic avenues, funneled inward toward the central regions. Along the way, compression triggers star formation in bursts and clusters. Observations show that these arms host some of the Milky Way's most luminous young stars. Blue, massive, short-lived giants, whose ultraviolet light sculpts the surrounding clouds. Their brilliance illuminates pockets of the galaxy that would otherwise remain hidden behind dust. The scene resembles lanterns hanging along a winding path, glowing with fierce but temporary light. The reflection follows gently. Even brief lives can affect the landscape around them. Closer to the sun's orbit, the spiral structure becomes more segmented. Astronomers have identified several prominent features: the Perseus arm, the Scutum Centaurus arm, the Sagittarius arm, and the thin Orion spur where our solar system resides. These structures overlap, break apart, and reform as density waves interact with gas, stars, and gravitational feedback from supernovae. Gaia's data suggests the arms are not perfectly continuous. Instead, they form a patchwork of segments connected like drifting branches of a vast cosmic tree. Each segment moves with the disk, but evolves independently, shaped by local events and long-range gravitational influences. The visualization feels peaceful, intertwined branches extending outward, each holding clusters of light. The feeling beneath the image reminds us, structure can emerge from patterns that aren't perfectly uniform. The galaxy's rotation influences everything, creating differential motion across the disk. Inner regions rotate faster than outer ones, stretching and twisting spiral arms over time. This rotation, combined with gravitational interactions, produces the gentle asymmetries that define the Milky Way's appearance. Astronomers model these dynamics using millions of simulated particles, watching as spirals form, dissolve, and reform in a slow, stately cycle. Their behavior reveals that spiral arms are not fixed structures. They are continually renewed waves, moving across a sea of stars. It feels like watching ripples move across the surface of a lake, present for a moment, then reshaping into something new. The calm insight that follows, stability and change often coexist. As the inner galaxy reveals its complexities, one truth becomes impossible to ignore. Every region influences every other. The bar shapes the bulge affects the inner arms, the arms guide gas toward the center. Satellite galaxies tug on the disk. Dark matter sculpts the halo. Each component interacts in delicate ways, forming a cohesive, interconnected whole. The Milky Way is not a rigid machine, but a living pattern of motion. Its behaviors layer atop one another like soft harmonies in a long, slow symphony, and from that harmony emerges a gentle realization. Nothing exists in isolation, not even stars. The journey now opens outward, toward the galaxy's farthest regions, a place where structure loosens, light fades, and the scale becomes almost impossible to grasp. Far from the glowing arms of the Milky Way, there comes a point where starlight begins to thin like breath on a cold window. Out here, the brightness that once felt abundant grows delicate, stretched across vast distances until even entire star clusters appear as faint smudges against the dark. This outer region, often called the stellar halo, is where the galaxy transitions from something familiar into something ghost-like, still present but quieter, older, and almost completely stripped of form. Astronomers observing this region note that the halo contains some of the Milky Way's most ancient stars. Their orbits are elongated and tilted at sharp angles, unrelated to the organized rotation of the disk. Many of these stars were born in small galaxies, long since absorbed by the Milky Way, leaving their remnants scattered like grains of memory drifting through the dark. The image feels lonely but beautiful, isolated sparks suspended in an endless night, each carrying a story no one else remembers. A thought settles with unusual softness. Even in solitude, there is meaning. The further outward one goes, the more fragments of ancient mergers appear. Long tidal streams wrap around the galaxy like strands of silver thread, stretching across tens of thousands of light years. These streams are the remains of dwarf galaxies pulled apart slowly, their stars stretched into elegant arcs by the Milky Way's gravitational pull. Some streams are well-defined, shaped by coherent orbits. Others dissolve into diffuse trails, their edges soft and feathered. Gaia's data continues to reveal new ones, each stream a lingering trace of something that once was whole. Together, they form an enormous web of motion weaving through the halo. It's easy to picture them as quiet echoes, looping around the galaxy in paths that take eons to complete. From that image emerges a gentle truth. The universe does not forget what it has touched. At still greater distances, the Milky Way's faint outer halo begins to blend with intergalactic space. Stars become rare, gas becomes tenuous. The distinction between galaxy and not galaxy grows vague, like a watercolor border, where colors fade into one another. There is no sharp edge, only a gradual dissolving of structure. Even dark matter becomes more diffuse, forming a soft gradient rather than a boundary. The halo may stretch nearly 1 million light-years from the center, but human intuition struggles to imagine such distances. The scale exceeds our sense of space, leaving only an emotional impression of vastness. In the mind, it becomes a horizon where the Milky Way slowly exhales into the void, wide, calm, almost wistful. The reflection that follows is quiet. Endings rarely arrive as abrupt lines. More often they fade gently away. One of the most mysterious discoveries in this region is the presence of ultra-faint dwarf galaxies. These galaxies are so dim that they were invisible to astronomers until the last 2 decades. Each contains only a few thousand stars, held together by massive envelopes of dark matter. They orbit the Milky Way like tiny lanterns drifting at the edge of a forest, barely glowing but undeniably present. Their existence challenges models of galaxy formation. Some may be survivors from the early universe, left mostly unchanged since the era when the first structures emerged after the Big Bang. Others may be the faint remains of galaxies partially devoured by the Milky Way, their brightest stars stripped away long ago. The image feels delicate, little clusters flickering like insects in the distance, fragile but persistent. A thought takes shape. Significance isn't determined by brightness. Beyond them lies the Magellanic Stream, a long tail of gas drawn from the large and small Magellanic Clouds. This stream spans more than half the sky, arcing gracefully across the halo. For decades, astronomers struggled to understand its origin, but high-resolution simulations now show that gravitational interactions between the Magellanic Clouds and the Milky Way created this river of hydrogen. The gas moves slowly, forming filaments that shift over millions of years. Some portions fall toward the Milky Way, fueling future star formation. Others stretch outward, thinning into the void. It is a structure without urgency, shaped by tides, time and proximity rather than force. Visualizing it, a serene ribbon unspools across the night, drifting with a patience only the cosmos can sustain. And the thought accompanying it is calm. Even separation can create beauty. Another haunting feature of the halo is the presence of stellar shells, faint arcs marking where small galaxies collided with the Milky Way. These shells form when stars from a disrupted galaxy bunch together temporarily before dispersing again. Their arcs appear like ghostly ripples frozen in time, visible only through deep surveys. Some shells contain stars that are chemically distinct from those in the disk, carrying signatures of their original homes. Their presence tells astronomers when mergers occurred, how massive the galaxies were, and how long their remnants have been drifting through the halo. The mental picture becomes that of soft rings expanding across a pond, but slowed to the pace of cosmic time, ripples that take 1 billion years to fade. Reflection arises effortlessly. Memories may blur, but their outlines remain. In these distant regions, gravitational influences from other galaxies begin to whisper. The Andromeda Galaxy, though more than 2 million light-years away, exerts a subtle pull on the Milky Way's outer halo. At this extreme distance, the halo is no longer shaped solely by our galaxy. It becomes part of a larger gravitational conversation. Simulations show faint bridges of dark matter forming between the Milky Way and Andromeda, threads connecting their halos long before their eventual collision. These threads alter the motions of distant stars, bending them gently toward future interactions. The imagery becomes melancholic. Two massive beings drifting slowly toward one another across a dark, silent sea. The thought rests softly. Even vast separation can hide quiet connections. The outer halo also contains a faint population of blue horizontal branch stars, which serve as markers for distance and structure. Because these stars have predictable brightness, astronomers use them as cosmic yardsticks, mapping the halo's shape with surprising accuracy. Their distribution reveals clumps, voids, and pathways left by long-gone galaxies. Their cool blue glow feels lonely but elegant, like frost illuminated by moonlight. They carry no drama, only clarity, a quiet signal against the dark. A sense of stillness settles into the reflection. Illumination doesn't need to be loud. Moving farther toward the boundaries of the halo, one encounters regions where dark matter dominates entirely. In these zones, stars are so sparse that gravitational maps become the primary tool for understanding structure. Dark matter creates soft dips and rises in the gravitational field, subtly guiding the orbits of nearby stars. The halo's shape is not spherical. It may be elongated, lopsided, or tilted. These distortions hold clues to collisions that shaped the Milky Way's past and to the influence of unseen structures drifting through space. One can imagine this region as a vast, translucent medium, not empty, but filled with invisible density, thicker in some places, thinner in others, like currents in deep water. The insight that forms is gentle. The unseen often carries the greatest weight. Eventually, even those faint traces thin until almost nothing remains. At this boundary, the Milky Way stops feeling like a home and begins to resemble a quiet memory, a glow in the distance, a faint reminder of where the journey started. The edges of the halo fade into the intergalactic medium, a realm of extremely sparse gas and weak radiation. This region is vast, cold, and nearly silent, yet it holds a soft tranquility. There is no conflict here, no structure fighting to maintain shape, only gentle dispersal. In the mind, it becomes a picture of a candle whose flame has shrunk but still glows, patient and unbothered by the surrounding dark. And the concluding thought drifts in. Sometimes endings are simply transitions into wider space. As the outer halo dissolves, one truth becomes clear. The Milky Way is larger, older, and more complex than human senses were ever built to comprehend. Its edges blur into mystery. Its history stretches across forgotten epochs, and its presence touches regions so distant they may as well be other worlds entirely. And yet, we are part of it. A small home orbiting a modest star, drifting peacefully inside a galaxy that breathes slowly across cosmic time. With that realization, the journey turns inward once again, preparing to explore the final layers of the galaxy before everything fades into the long quiet of intergalactic space. Somewhere between the fading glow of the halo and the bright hum of the disk lies a realization that feels strangely personal. Our place in the Milky Way is impossibly small, yet profoundly significant. The sun's orbit traces a gentle path around the galaxy, a path that has followed more than 20 times since Earth formed. Every moment of human history, every breath, every story, every hope, has unfolded during a single fraction of one galactic year. Astronomers estimate that Earth has drifted through different spiral arms, crossed above and below the galactic plane, and moved through regions of varying density. Each shift likely influenced the conditions on our planet. Some studies even suggest correlations between cosmic radiation levels and mass extinctions, hinting that the galaxy's rhythms may shape life in ways we barely understand. The thought feels delicate. Life on Earth is not separate from the Milky Way. It is woven into its motion, and that connection carries a quiet humility. The sun itself may not always have traveled alone. Research into the birth environments of stars suggests that most form in clusters, surrounded by siblings that disperse over time. It's possible that our star once shared the sky with other suns, bright neighbors illuminating the early solar system before drifting away into the vastness. Scientists search for these long-lost siblings by analyzing stellar chemistry, looking for stars with identical elemental fingerprints. A few promising candidates have appeared, suggesting that somewhere out there, stars formed from the same cloud as the sun still wander the Milky Way. They may be older, brighter, or dimmer, but they carry the same cosmic DNA. It's a strangely comforting image. Distant siblings, separated not by choice but by the natural dispersal of motion. The feeling underneath says something simple. Family can exist across unimaginable distance. Our position in the Orion Spur plays its own role in shaping Earth's history. This small branch of a spiral arm is relatively calm compared to denser regions closer to the galactic core. There are no frequent supernova clusters nearby, no chaotic environments that could bombard Earth with harmful radiation. Instead, the solar system drifts in a quiet neighborhood, stable, modest, and gentle. That tranquility may have allowed life to flourish uninterrupted for billions of years. A more turbulent region might have sterilized the planet long before humans appeared. Our entire existence may rely on the subtle luck of cosmic geography, a location neither too crowded nor too empty, neither too bright nor too dark. The metaphor becomes clear. Sometimes the quietest places create the conditions for life to grow. And realizing that inspires a soft gratitude. Yet even this calm region is not entirely still. The solar system oscillates vertically through the galactic plane, rising and falling over tens of millions of years. Each oscillation alters the cosmic environment slightly, exposing Earth to different mixtures of radiation, dust, and gravitational influences. The journey resembles a slow cosmic tide, lifting and lowering our world as it drifts forward. Scientists debate the effects of these vertical movements, but the idea itself is poetic. Earth isn't stationary. It rides a soft wave through the galaxy, carried by the sun's gentle sway. The motion is slow enough to be undetectable in a human lifetime, yet persistent enough to shape the long arc of planetary history. Visualizing this, the solar system becomes a lantern swinging from an invisible thread, rising and falling in near-perfect silence. The accompanying thought is peaceful. Movement does not mean instability. The galaxy's large-scale structure also shapes the cosmic radiation that reaches Earth. Supernovae, neutron stars, and cosmic ray accelerators scatter high-energy particles across the Milky Way. Yet the distribution of these sources is uneven. The sun's position protects Earth from many intense radiation fields found in other regions. Dense star-forming zones, for example, host frequent supernova explosions, spectacular but potentially dangerous to fragile biospheres. Being far from those zones may have shielded Earth when life was young. It's a reminder that safety and vulnerability are not constants, but consequences of location. The galaxy offers no guarantees, only regions of relative quiet where complexity is allowed to take root. The image feels tender, life growing in a sheltered corner of a vast, unpredictable home. The reflection that follows is honest. Existence is fragile, but that fragility makes it precious. Further outward, stars move with a freedom that reflects the gravitational shape of the galaxy. Their orbits can be wide, elongated, or inclined, showing that the Milky Way is not perfectly symmetrical. These asymmetries preserve clues to the galaxy's past interactions, collisions, mergers, and tidal disruptions that reshaped its form. In these motions lies the memory of the universe, written not in words, but in trajectories. A star drifting through the halo carries within its orbit a story billions of years old, the signature of forces that acted long before Earth existed. The mental picture becomes somber, but beautiful. Ancient stars gliding through the night, unaware of the stories they tell simply by moving. The thought lingers gently. Memory can be carried in motion as well as in stillness. Even the shape of the dark matter halo influences our place in the galaxy. If the halo is elongated or tilted, as many models suggest, that changes the gravitational landscape the solar system travels through. Minor differences in density can subtly alter the sun's path, shifting the timing of its oscillations and interactions. We cannot see these influences directly, yet they shape our world. Dark matter, silent, invisible, unfelt, provides the scaffolding that keeps the Milky Way intact. Everything familiar, everything we depend on, floats within that invisible structure. Imagining this feels like standing inside a cathedral whose architecture is entirely made of air, present, holding everything but unseen. The emotion behind it is quiet awe. Existence rests on foundations we cannot perceive. The concept of scale grows more abstract. The farther outward one travels across the galaxy, distances stretch into millions of light years, time blurs into epochs, and human intuition begins to fail. Even the most seasoned astronomers describe these regions with humility, aware that their understanding is always incomplete. To think of the galaxy's outskirts is to confront the limit of human perspective. Our senses were not built for this. Our brains evolved to understand forests, rivers, seasons, not halos spanning 1,000,000 light years or tidal streams older than civilization itself. Yet the attempt to understand brings its own quiet beauty. It is the act of looking outward, gently, knowing the view will always exceed our reach. The reflection that rises is soft. Wonder begins where comprehension ends. Earth's place in the Milky Way also carries a subtle emotional weight. The galaxy is enormous, ancient and indifferent, yet it has shaped every aspect of our existence. Our bodies contain elements forged in distant supernovae. Our sun was born from clouds sculpted by earlier generations of stars. Our world spins within a galaxy that has protected, influenced, and carried us since before there were humans to observe it. Thinking of this creates a strange blend of smallness and belonging, as though we are both insignificant and deeply connected at the same time. The feeling is bittersweet, but comforting. In the outermost regions, the Milky Way begins to resemble a memory more than a place. Its structures fade into the dark, its light becomes thin, dispersed. The gravitational pull weakens, giving way to the quiet drift of intergalactic space. Here, the galaxy feels like something distant, a home seen from the edge of a great shore. And yet, even at this extreme distance, the Milky Way's presence remains. Its gravity continues to guide stars, streams, and dust. Its halo touches the halos of neighboring galaxies, forming bridges that link cosmic islands across the void. The imagery is gentle, a faint glow behind you as you step into a wider night. And the thought that follows holds a touch of melancholy. One can love a place even as one drifts away from its light. But no matter how far outward the journey goes, the truth persists. We belong to this galaxy. Our atoms, histories, and futures are tied to its motion. Every distant region, every tidal stream, every quiet star is part of the same system that carries our small world forward. The Milky Way is vast, but it is also our home, a home whose structure stretches across time, space, and memory. And with that feeling, the path opens into the final chapter of this journey, the moment when the galaxy meets the greater universe beyond it. There comes a moment in this journey when the Milky Way no longer fills the view, when its familiar spiral fades into something distant, soft, and almost fragile. At this threshold, the galaxy shrinks from a landscape into an object, a glowing swirl suspended in darkness. For the first time, the mind sees it not from within, but from the outside, and the scale becomes overwhelming. What once felt enormous now fits gently into the frame of a single thought. Observations from deep surveys like the Sloan Digital Sky Survey reveal how galaxies appear from afar. Luminous islands surrounded by near-perfect darkness, each one drifting alone, yet influenced by unseen threads. When imagining the Milky Way from this vantage point, it behaves like any other galaxy, a slowly turning structure shaped by gravity and time, unaware of the lives unfolding inside it. The mental picture feels quiet, a soft lantern in a vast night, glowing but distant. And with that image comes a realization. Perspective reshapes meaning. Beyond the halo lies intergalactic space, a region so empty that it challenges the very definition of emptiness. Between galaxies, the density of atoms drops to just a handful per cubic meter. Light travels through these regions for millions of years without interruption. There is no air, no dust, no gas dense enough to gather. Only faint radiation and drifting particles remain. Yet this void is not entirely featureless. Filaments of dark matter span these distances, forming an invisible scaffold that connects galaxies into a cosmic web. Matter flows slowly along these filaments, shaping the positions and motions of galaxy groups, clusters, and superclusters. In imagination, the web resembles fine silk stretching across a giant, dark expanse, delicate, silent, and impossibly large. The feeling that accompanies it is simple. Structure exists even where the eye sees nothing. The Milky Way participates in this cosmic web as part of the local group. This small assembly includes the Andromeda Galaxy, the Triangulum Galaxy, and dozens of dwarf galaxies drifting in a gravitational dance. The local group spans several million light-years, held together by a shared gravitational field that keeps its members from drifting apart indefinitely. Within this group, the Milky Way and Andromeda dominate, their combined masses shaping the region's dynamics. They drift toward each other at roughly 110 kilometers per second, a pace slow enough to be imperceptible within any human time frame, but fast enough to ensure a future collision 5 billion years from now. Visualizing this, the two spirals seem like massive clouds floating across a still lake, moving closer by fractions of a ripple over unimaginable time. The reflection comes naturally. Even immense journeys begin with small movements. When Andromeda and the Milky Way finally meet, the collision will not be a violent explosion, but a slow interweaving of stars. Galaxies are mostly empty space. Their stars rarely collide. Instead, they pass through one another like overlapping storms, distorting shape through gravity rather than impact. Simulations from NASA's Hubble team show that the spirals will stretch, twist, elongate, and eventually merge into a single elliptical galaxy. Over billions of years, the two rotating disks will lose their structure, replaced by a rounder, more diffuse form where stars move in random orbits rather than organized spirals. The imagery becomes surreal. Two bright spirals drifting through each other, unraveling their arms, weaving their stars like threads in a slow-motion tapestry. The thought that emerges is peaceful. Endings can be transformations rather than losses. During this merger, the night sky from Earth would change dramatically. Andromeda would grow brighter over millions of years, eventually dominating the view with curved in glowing arms stretching across the horizon. New star formation would bloom as gas clouds collide and compress, creating bright nebulae and clusters. The galaxy would become more vibrant, more dynamic, more alive, but humanity will likely be long gone by then. Whether extinct, evolved, or carried elsewhere, our species may witness these events only through imagination and distant prediction. The cosmos moves on scales incompatible with biological time. This creates a strangely tender feeling. The universe continues its dance whether or not anyone watches. The reflection settles gently. Permanence is not required for meaning. Beyond Andromeda lies the larger gravitational structure known as the Virgo supercluster. This colossal concentration of galaxies is so vast that light takes tens of millions of years to cross it. The Milky Way sits on one of its filaments, drifting slowly along a gravitational basin. There is no sharp boundary, just a gradual transition from one region of influence to another. Deeper still is Laniakea, the immeasurable heaven, the supercluster to which the Milky Way ultimately belongs. This vast region contains hundreds of thousands of galaxies, all flowing along gravitational pathways that converge on a region called the Great Attractor. Its pull is so powerful that even the expansion of the universe cannot fully counteract it. The mental picture stretches the mind. a river of galaxies flowing together through a cosmic valley. And the feeling is awe. Existence participates in something so much larger than itself. But even superclusters have limits. On the grandest scales, the universe is dominated by expansion. Galaxies, not gravitationally bound to one another, drift apart as space itself stretches. Distant regions recede faster than light, slipping beyond the cosmic horizon where no future signal can ever reach us. This means the universe has a visible boundary, not a physical edge, but a limit to what can be seen or influenced. As time passes, more galaxies will drift beyond this horizon, leaving the local group increasingly isolated in a growing dark. Imagining this evokes a quiet solitude, islands of galaxies drifting farther apart, each one becoming its own universe. The thought lands with melancholy. Connection fades when distance grows without limit. From the vantage point of intergalactic space, the Milky Way becomes a story. Its spirals, its halo, its streams are reduced to a single glowing structure drifting through the dark. All life, all history, all memory compressed into one faint swirl of light. This scale does not diminish us, it contextualizes us. It reminds us that our existence is fleeting but real, small but luminous. We are made of the galaxy's dust and carried by its motion, part of a pattern far older and wider than anything we can fully understand. The image is profound, a single spark drifting across a wide ocean. And the quiet realization that follows is gentle. Meaning is not measured in size. As the view widens farther still, the entire cosmic web becomes visible. Filaments stretching across billions of light years, clusters glowing at their intersections, and deep voids spreading like great silent wells. In this panorama, galaxies appear as specks of dust, and yet their arrangement forms the most intricate structure ever observed. Every filament, every void, every cluster exists because of forces initiated moments after the Big Bang. The story of the universe is written in these large-scale patterns, a script made of gravity, matter, and expansion. The mental image resembles lace stretched across an obsidian canvas, delicate, immense, and almost impossibly beautiful. The reflection follows softly. The universe is not chaotic. It is structured poetry. At the edge of this boundless network, one finds the faintest hint of something beyond comprehension. Not another structure, not another galaxy cluster, but the simple recognition that even this view is incomplete. The universe may extend farther than any instrument can detect. It may curve, fold, or expand into dimensions we cannot perceive. And so the Milky Way, at vast, intricate, astonishing, becomes a starting point rather than an end. A doorway to deeper mysteries, a reminder that wonder is not something we finish, but something we continually open. The feeling is serene. Curiosity is endless because the universe is endless. With this recognition, the journey returns inward. Not back to the galaxy, not back to the solar system, but back to the listener, the small point of awareness drifting through these cosmic images. All of this, the halo, the voids, the clusters, the expansion, settles into a single, gentle truth. Existence is more vast, more delicate, and more interconnected than any one perspective can hold. And as the imagery softens, the final realization emerges with quiet clarity. Drifting through the universe is not something stars do alone. We drift too. As the journey settles, the vastness we've crossed begins to fold itself into something quieter, something that feels less like distance and more like perspective. The Milky Way, once an overwhelming swirl of stars, gas, and mysteries, now rests gently in your mind as a familiar presence, a home you've been floating within your entire life without ever noticing its slow, patient motion around you. Every image we explore dissolves into a calm awareness that you belong to this place, not by choice, but by origin. The thought of drifting through such enormity no longer carries the weight of insignificance. Instead, it creates a soft gratitude. The galaxy may be immense, but it is also intimate in its own way, shaping the world that shaped you, protecting your small corner of existence with quiet forces you never had to worry about. Gravity held you long before you knew what gravity was, and starlight warmed your world long before you understood stars. Looking back at the galactic core, the spiral arms, the halo, and the distant boundary where everything begins to fade, a gentle pattern emerges. Motion, connection, dissolution, renewal, all of it mirrors the rhythms found in smaller scales of life. The galaxy spins, breathes, stretches, changes. It absorbs old structures, creates new ones, and carries each star along paths shaped by histories older than memory. There is something comforting about recognizing that you are part of that rhythm, that the same laws guiding stars also guide the atoms in your body. And as the imagery widens farther into the cosmic web, the mind starts to accept something deeper, that the universe does not require understanding in order to offer meaning. Wonder is not a conclusion, it is a constant state, renewed each time you look beyond what you already know. Even the unknown feels softer now, less intimidating, as if it, too, is simply part of the broader pattern of existence. The galaxy's immensity doesn't distance you from it. It folds you into its story. Your atoms were forged in ancient furnaces, scattered across long-forgotten corners of the spiral arms. The iron in your blood once drifted through the halo. The calcium in your bones condensed from clouds shaped by the breathing of the disk. You have always carried pieces of the Milky Way within you, not symbolically, but literally. Everything you are began as the afterglow of old stars. This understanding carries a quiet warmth. Smallness is not the opposite of significance. In a universe built from relationships between things large and small, your presence is as legitimate as a galaxy's motion or a star's light. You are a participant in the same structure, woven into the same physics, drifting with the same currents that guide worlds and nebulae across billions of years. So as this journey slows, take a moment to feel how the galaxy holds you without asking anything in return. The night sky above isn't just a scattering of distant lights, it's a map of your origins, a silent reminder that you belong to something magnificent and ancient. Even if life feels chaotic or uncertain, the cosmos beneath it all remains steady, patient, and profoundly beautiful. And if these quiet explorations of science and wonder bring you peace at the end of your day, I'd be truly grateful if you could leave a like and subscribe to the channel. It helps others find their way into this calm corner of the universe as well. And before you drift off, tell me in the comments where you are tonight and what time it is there. I love hearing from the travelers who share these moments. As we close, hold on to one final image, the Milky Way glowing softly in the dark, and somewhere inside it, you want a small point of awareness floating in a vast ocean of light, yet never truly alone. Your presence, your thoughts, your quiet attention add something gentle to the world, like a distant star contributing its faint shimmer to a sky that wouldn't be the same without it. Sleep well, traveler. The galaxy will keep drifting, and so will you, carried forward on currents older than time, wrapped in the quiet rhythm of a universe that has room for every form of light.